All right, so we're going to move on to section 4.2. You can label it sigma notation. And that E-looking thing, if you recall from the last couple of years, is called sigma. It's a Greek symbol, and it actually, what does it mean? The sum of, the summation. It means to add things up. So if I give you some function f of x and I ask you to figure out what is the value of that function for the first, say, 5 terms, you would evaluate the function at the first term, the second term, the third, the fourth, and the fifth, and then you'd add them all together. Sometimes it's easy to do that. Sometimes it's a little bit more detailed. So I'm going to show you some tricks along the way. So the I equals 1 at the bottom, that just tells you that that's where you start. So we are starting in this case with the first term, and then the number at the top, in this case an n, it just means that your last number would be n, whatever n is. So I gave you an example there. Find the sum of this function for the first 5 terms. So from the first term all the way to the 5th term. So your job would be to evaluate this function when I is 1, when I is 2, 3, 4, and 5, and then add them all together. So if I plug a 1 into this function, what is the value of that function?
2.
It would be 2. So we'd have a 2 plus. And then if you put a 2 in for I, you'd have 2 plus 1, which is 3. And then if you put a 3 in for I, you'd have 3 plus 1 is 4. And then if you put a 4 in, you'd have 4 plus 1, which is 5. And then if you put a 5 in, you'd have 5 plus 1, which is 6. And then you would add them all together. So what is 1 plus, not 1, 2 plus 3 plus 4 plus 5 plus 6, which you get? 20. You get 20. So the value of this function would be 20 for the first 5 terms. All right. Of course, they're not always going to be, that simple. Can I flip? Are you guys good? What about this one? It doesn't start at the first term. It starts at the 3rd term. And you end at the 7th term. So in this case, you would plug in a 3 for x on the top, which would be 3 over, and then on the bottom we would have 3 minus 1, which is 2, plus. Then you go on to the 4th term, which would be 4 over what? 4 over 3. And then you go on to the 5th term, which would be 5 over 4. And then you move on to the 6th term, which would be 6 over 5. And then you move on to the last term, which would be 7 over 6. Now, you could certainly add all of those things together by finding a common denominator and blah, 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 blah. But, you certainly can just type 3 divided by 2 plus 4 divided by 3 plus 5 divided by 4, etc. No parentheses necessary when you're typing this into your calculator, okay? You just type it in just as you see it. The calculator knows to divide out the fractions first and then add together all the answers. You will get a terrible decimal. Did anybody do this yet? Matt, and then you change it back to a fraction. And I got 129 over 20. Lynn, do you agree? I'm talking to you.
Nope. My calculator doesn't.
You sure it's not the operator?
Ouch. I don't want to be in this class anymore. It's the operator. She just put 1/3. Shh.
Okay, let's say you have a really large list of numbers to find. So, for example, I'll give you an example in just a minute, but let's say you don't just have to add together 5 numbers or 7 numbers or 10 numbers. It's lengthy. You have to figure out a lot of numbers added together. That's when we need to start talking about some tricks and some rules that you can use. So, you may have heard this story before because I know it comes up in the pre-calc book. There was a German mathematician by the last name of Gauss. Does anybody remember this? No. His last name is Gauss, and we are talking like a really, really long time ago, like before I was even born. No, seriously, a really, really long time ago, like way, way before you or I were born. There was this German mathematician by the last name of Gauss, and he was asked by his teacher. You know what? You probably don't have to write this down now. He was asked by his teacher to find the sum of the first 100 positive integers. And I think, if I've heard the story correctly, that the teacher gave him that to do, gave the class that to do, just to shut them up, just so that he was a he, because girls didn't teach back then, because girls were supposed to be home cooking. So the teacher had asked the class to add together the first 100 minutes, just to buy some time. And this mathematician, very famous mathematician now, came up with a very, very quick, easy way to do this. So this is what this is what he did. He said, okay, well, I'm adding together 1 plus 2 plus 3 plus 4 plus 5 all the way to 100. So, yeah.
Can we do it?
Sure.
You go, girl.
Okay. She's heard the story before, I
Yeah.
believe.
Like the first and the last one will be. And second and this one will be. And like it continues. 3 and here is 99, 98, and 398 will be 101, and it will continue. And since we're adding 2, it will be altogether 50. So you just like. And it will be 1,000.
Yes, she was right.
What?
Do you get what just happened?
No.
So this is what he did. He took the first number and the last number and knew that if you add together 100 plus 1, you would get 101. The same thing will happen if you add together 2 and 99. And I should have probably listed before. I shouldn't have just ended it with 100. I should have ended it with 97, 98, 99, 100. But if you add together 2 and 99, you will get 101. If you add together 3 and 98, you will get 101. Do you understand what I'm saying? So you do that until you get all the way out to 50 and 51. Okay, so how many times are you coming up with 101?
50.
You're coming up with that 50 times. So he said, okay, well, it's 101 times 50, which is 5,050.
How old was he when he came up with this?
In school,
So
in high school-ish, whatever it was called back then, I don't know. So he was young. Yeah. And you know what? And I'm sure at that point, he did not, I mean, I'm sure his teacher wasn't shocked that he could come up with something that quickly. Maybe disappointed, because I think I've heard the story that he wanted time to get something done. He didn't get the time because he came up with it so quickly. So, but I'm sure that you know, I mean, I wouldn't be surprised if the teacher knew that he would be able to come up with it that quickly. Very, very brilliant man. So. All right, are you okay with that? All right, so I'm going to set it up a little bit differently so that I can explain something else to you. What I'm going to do is this. I have 1, I have 2, I have 3, etc., all the way out to 98, 99, and 100. And I am going to list the same numbers backwards. So I'm going to put the 100 under here. I'm going to put the 99 underneath there. The 98 underneath here, etc., 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 all the way down to 3, 2, and 1. Are you with me? And then we have the pairs that go in between here too. Are you all right with that? So what happens when you add together 1 and 100? 100. What about 2 and 99? 101. What about 3 and 98? Okay, same thing. Over here, same thing, we have 101. We have 101. Here we have 101. So he added together 101, 101, 101, 101, 101. How many times did he do that?
50.
No, he didn't.
Wait, what?
Well, he may have. I have heard this story. It doesn't matter. It's a variation of the story. But I have heard that this is what he did. 101, 101, 101. But he went all the way down. He did this all the way to 100.
Oh, so 100
And got 100 and continued to get 101. So he got 101 100 times. Are you okay with that?
Mhm.
But that was how many times too much? He did it 50 times too much. So in other words, what he had to do afterwards is he had to divide it by 2. Because that was twice as many addings that he had to do. So it's twice as many 101s. So what is 101 times 100 divided by 2?
5,000.
It's 5,050. So either way, it's the same answer. And who knows exactly what he did, but it was the same idea regardless, all right? So literally, if you add together 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 all the way to 100, your sum would be 5,050, okay?
So what if you don't go to 100? What if you go to 23?
Then we'll talk about that.
Okay.
All right, so based on that, mathematicians have come up with a rule, one of a few different, there's a whole bunch of summation rules. We are going to talk about 4 of them, the first one being this. So let's write down summation rules, probably you're going to use these quite a bit, so let's put it underline it, star it, something. And the first summation rule says this: to find the sum of I, in other words, a linear function, something that's linear. Was Gauss's list of numbers linear? How do you get from 1 to 2?
Add 1.
How do you get from 2 to 3?
Add 1.
Yeah, how do you get from 2 to
3.
Did I say that right? 2 to
Yeah.
3? You're constantly adding 1. So his string of numbers was a linear situation. Okay? So let's say that we have to add this together. Starting with the very first term, this only works if you are starting with the first term and you are ending with the nth term. So whatever the nth term is. What was Gauss's? What was his n? It was 100. And remember, he came up with this. 101 times 100 divided by 2. So this 100 is really the n value. And what is the 101? It is how much more than the n value? It is 1 more than the n value. And then he divided by 2. Come to find out, that works with any linear sequence. So if you are starting with 1 and ending with the nth term, and the sequence is linear, we might want to write that down. This is linear. This is all you have to do. You take the n, in this case it's just an n, you multiply it by n plus 1, and what do you do to it? You divide it by 2. This is the rule that you need to know and learn and use. Can you look back at it? Absolutely. Will I give it to you on a test? I don't know yet. I think so, but I don't know for sure yet, okay? Probably. All right. So this is Gauss's. This is his 100 terms. This is 1 more than the term. Then you divide it by 2. Second rule is this. The sum from 1 to n of c. What does that mean? A constant. So I'm going to write this down. If you have a constant. All you have to do to figure out the sum of that is to take that constant value, whatever, say it's a 4, you would take 4 and you would multiply it by the number of terms that there are. So it would be c times n. So what I mean by that is this. Let's say that you have this kind of a sequence. You need to add up the numbers starting from the first term and ending at the fourth term of 3. Well, 3 function. Regardless of what the input value is, it's always 3. So the first term is a 3. What's the second term? It's a 3. What's the next term? What's the next term? Okay, what is 3 plus 3 plus 3 plus 3? 12. So all you really had to do was take 3 and multiply it by the number of terms that are in the sequence. So it's just 3 times 4. So in other words, the constant value times however many terms are in the sequence. All right, next rule, number 3. I think that one's a pretty easy one. So this one, let's say you are starting with the first, you are ending with the nth, and we're talking about I squared. So what does that mean? It's not linear, it's not constant, it is not exponential, quadratic. So let's talk about that, John. Quadratic, which in the exponential means that the x is a power. In this case, the power is a 2. That's a really common mistake. So, okay, I squared equals, this is the rule. You take n, you multiply it by n plus 1, you multiply it by 2n plus 1, and you divide that by 6. That's the rule. Accept it, use it, learn it. Yes, I will.
Why is it that little?
I don't know. I mean, I don't really know. I'm sure that we could probably Google it and figure out why it is that, but I don't have a story for it. Okay? All right, an example. Let's say that we go from the first term to the 10th term of I squared. Well, that really means 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared all the way up to 10 squared. But there's a much quicker way to do it than to go 1 squared plus 2 squared plus 3 squared and then add them all together. We can use this rule. So what is n?
10.
That is 10. What is n plus 1?
11.
11. What is 2 times n plus 1?
21.
21 divided by 6. What is 10 times 11 times 21 divided by 6? 385 is what I got also. All right, there's another one, and this is the last one that I'm going to expect you guys to know. You know what? I'm going to put it on a new page. Number 4. Did I go too fast? Do you guys need to see that?
Can I ask a quick
I'll just
question?
use
Yeah.
mine. It's okay.
How do you?
Alright, so, like, what if it's like I squared plus 3 or something?
You are 2 steps ahead of me. We'll get there.
Okay.
Yep. Yes.
So these rules only work when I equals 1, right? So when I equals like 0 or a number.
If I starts anywhere but 1, then you have to go back to your old-fashioned method, which would be that you would add, you put 3 into it, then you put 4 into it, and then you put 5 into it all the way to where it ends. And the ones that I give you like that are pretty not very, they're not very big. They're not going to require a lot of calculating and adding together. The big ones will allow you to use this rule. Okay? Did everyone hear John's question?
No.
He just said, what happens if it's not just I squared? What if there's an I squared and an I in it? And we'll get to that in just a minute. I have one more rule to give you. 4th rule is this. Let's say we go from 1 to n, and it's cubed. So this is a cubic function. The rule is this, n squared times n plus 1 squared divided by 4. So that's the rule. I'm going to give you a quick example. Let's say that I'm having you calculate everything from 1 to 10 of I, let's just do I cubed. Of I cubed. And we're going to use that rule. So we could go 1 to the 3rd power, plus 2 to the 3rd power, plus 3 to the 3rd power, and so on. But there's a quicker way. This is the rule that you use. You take n and square it. What's n? 10. So we have 10 squared. Then we take n plus 1 squared. So n plus 1 would be 11 squared is 121. And then we divide that by 4. So I should have just written 100 here, not 10 squared. So it should be 100 times 121 be 12,100. Divide that by 4, and you got 3,025.
Yep.
We agree? All right. So now let's get to a good example now. And this is the last thing I'm going to show you, and then you guys have some time. Okay.
Free?
Did you just say 3 times?
No, I said they were free.
Then you're free. Yes, you are free. All right, example. This is getting back. This goes along with what John was asking. All right, so we are adding up all of the terms from the first. I'm going to keep it low. I'm going to keep it to the 5th. And now, and this one is, you're only going from the 1st to the 5th, so it would be not too bad to just add together the first 5 answers. But let's practice using the rule. So let's do I times I plus 2. The first thing I want you to be looking for is, how can you simplify this? How can you simplify I plus 2? What is this the same
I
as?
squared plus 2i.
Very good. I squared plus 2I. That means the same thing. So your job would be to recognize that this right here you would have to use the squared rule for, the quadratic rule. And then this one right here, you would use the linear rule. So we have quadratic here. Here you have a linear.
Oh, so you have to combine them.
What'd you say?
You'd have to combine them.
You'd have to combine them. You'd have to do one of them, and then the other one, and then you combine your results. Okay? All right, so let's do, now this, you have to do this too. I want you to, you're going to need to do this. You're going to have to separate them. You go from the first term to the 5th term of I squared. You do this. And then do you see that coefficient out in front of the I for the linear part? Do this. Throw it in front of your sigma. Just put an I there. Now calculate it. The rule that I showed you works for only I, and this is just double I. So calculate it for I, and then double your answer. So by putting the 2 out front, it's just kind of telling you to just put it aside for now, calculate it with just I, and then multiply the 2 into your answer. It's kind of like parentheses, 2 times whatever you get for this part right here. All right, help me out here. I squared. Now, you guys, I have to be honest with you, I don't have the rules memorized. I'm sure you don't then either. So what is the rule for I squared? Leave myself enough room here. What is the rule for a square? N times n plus 1 times
2n plus
2n plus 1 divided by 6. All right, so what is n? In this case, it's 5. So we're going to do 5 times, and then it says
n plus 1.
n plus 1, so then now it's times 6. And then we do 2 times n plus 1, so 2 times 5 plus 1, which is 11. And then we're going to divide it by 6. So that's the first part. We took care of this. Plus, we're going to do plus, and then we have our 2, and then we're going to calculate the rest of this stuff. And then we'll multiply it by 2. So this part right here, what's the linear rule? That was the Gauss's rule. That one's kind of easy to remember. What is n? It's 5, and then n plus 1 is 6. But then it has to be divided by 2. Do you see the 2's cancel out?
Yeah.
Okay. So notice this too, we have a division problem right here. Do you see those 6's? They cancel out. Cancel out when you can. Is it for you? You made it through the notes. That's good.
Wonderful.
5 times 11 is 55. And then 5 times 6 is 30. What is the total? 85. Yeah.
I didn't set it up the way that you did.
Okay.
I like doing this.
did. I just didn't write it out the same way. Do you feel okay about this?
Yeah.
The assignment, your assignment, I already have listed up there. Answer keys already posted. The answer keys already on my website. You have to do 1 through 6, 15 through 20. I am going to tell you that 1 through 6. I can't remember if they're all like this, but they don't all start at 1. So you're going to have to do some calculating, you know, just by plugging the value in and then adding them together, okay? But 15 through 20 all require you to use the formulas I just showed you.
I was just gonna start.
I is the one that